Okay, so we're going to talk about using interval notation to represent a set. So a linear inequality in one variable is an inequality that can be written in the form ax plus b is less than c, where a, b, and c are real numbers and a cannot be equal to 0. Because if a is equal to 0, that makes that first term go away and you just have a number less than a number. B is less than c. So I've got a chart here, and this will give you an idea of what happens with a particular graph. So if, for instance, the first two, they don't have an equal sign. They just have x is less than a and x is greater than a. So those are going to have parentheses. Infinities, negative infinity always gets parentheses. So in these cases, it's always going to be that. And the other thing you need to be aware of is that you're always going to go from left to right for the interval notation. So in this case, it's going to be negative infinity to a, and this would be a to infinity because it's going this way. When you have the equal sign put into it, that's when you get a bracket, only on the side where the equal is for whatever that number is. The infinities still get parentheses. And then if you have something where something is between, so if x is between a and b, so it's greater than a and less than b, then we're looking at the interval notation being between two parentheses. Where the others, because it just was one side of it, it goes on forever to the infinity and negative infinity. Here we have it with the equal to's, so it's going to get the brackets. And here we have one that has does not have the equality, and this one has the equality. So you're going to get a parenthesis and a bracket, and if we switch that around, we're going to get a bracket and parenthesis. So that'll give you kind of a reference. So infinities always have your parentheses next to them. If there's a line, the number will have a bracket. No line, you'll have parentheses. Negative infinities are always on the left. Positives are always on the right. And it's easier if you graph your answer first, and then and on those I'll only put the needed numbers, and then you can copy the notation. We're going to do some examples, and you'll see that. For the graph, if it's a less than, the arrow will go left, and greater than, the arrow will go right. So let's do some examples of what we're talking about here. So we are going to graph each set on a number line, and then we'll write in interval notation. All right, so for example 1, we have x such that, and that's what that line means, is such that x is greater than or equal to 2. So first thing we're going to do is graph it. I need a 2, and I'm always going to put the infinities on either side. So x is greater than or equal to 2. So greater than, we're going to go to the right. And then because it's also got the equal, we're going to put a bracket. And then from here, we can copy straight down. So we end up with 2 comma infinity parentheses there. So this side gets the bracket because of the equation, or the equal part. All right, let's do example 2. So we have x such that x is less than negative 1. Well, we have less than, so we're going to draw our graph again. And we'll put our infinities on both sides, and we're only dealing with negative 1. And you can put lots of numbers, but sometimes when you're trying to do the notations of that, you just get bogged down by where are all the numbers at. So if you only just put what you need, sometimes it's easier. So less than will go to the left. And because it is not equal to, we'll have a parenthesis. And then we'll copy straight down. So negative infinity to negative 1 with a parenthesis. All right, let's look at example 3. So we have x such that 0.5 is less than x less than or equal to 3. So we have our negative infinity to infinity, and we have a 0.5, and we have a 3. So x is greater than 0.5, so that will go to the right. It is less than or equal to 3, so that'll go to the left. So they're going to meet here in the middle. So it's going to be this whole section right here. The 0.5 does not have an equal sign, so it will have a parenthesis, and this side does, so it's going to get a bracket. So our answer will be, for the interval notation, we just bring it straight down with a parenthesis in our bracket. All right, let's do example 4. We just have x is less than 7, so we're not doing all of the set notation there. So again, we're going to draw our graph. We have a 7, we have the infinities. It's less than, so it's going to go this way. And it doesn't have the equality, so we're just doing a parenthesis, so negative infinity to 7. And then we have example 5. X is greater than negative 4. So, again, we're going to do our infinities, and we'll do negative 4. It's greater than, so it's going to the right. And it doesn't have an equality, so it will be a parenthesis. Now, what I want you to be aware of is, yes, this points to the left and this points to the right, but if I rewrite this, this means the same thing. X is still less than 7. So it's not about the inequality and how it, or the inequality sign there. It is about how it's read. So this is x is less than 7. This is also x is less than 7. Same thing would happen down here. I could have this as negative 4 is less than x, or x is greater than, you should read it with the variable, x is greater than negative 4. Even though the inequality points that way, we're still going to the right because it's greater than. So don't let the fact about the arrows, well, it's facing that way, so that's the way I'm going. They're not really arrows, they're inequalities. And greater than or less than sign. So you don't want to go by how it's pointing because it could be written the other way. You need to understand that you read it from the variable. The variable is less than the number here, and the variable is greater than the number here. So that way you're not into that trick.